Welcome back to Statistics Tutorials using Excel. In this episode, we're going to take a look at how to calculate the test statistic and the p-value for a hypothesis test on the mean. So the first thing I want to point out is we're going to look at two scenarios. One is where we have the alternative hypothesis where mu is less than $2.95. And then the other one that we're going to take a look at is when we have the alternative is mu is not equal to $2.95. So we're going to talk about the test statistic and the p-value for these and how we calculate that using Excel. To my knowledge, there's not necessarily a built-in function that calculates the test statistic, so we have to write a formula in order to do that. What I did is I generated the summary statistics using the data analysis tool pack. And I have these values right here are my summary statistics. If you don't know how to do that, watch one of my other videos and it'll show you how to generate the summary statistics using the data analysis tool pack. So to calculate our test statistic for the t-distribution, if you recall, we have to take our sample mean and we have to subtract that from our population mean. I have all the values given right here. I'm going to use the value that actually came from this data set right here. One of the problems that I ran into is when I have this in dollars right here and I go through and I do the calculation, it gives me a calculation for my p-value in dollars, which a p-value is a probability. It should be expressed as a decimal value or a percentage. It should not have any units attached to that. So anyways, if you recall with the numerator of the test statistic, we have our sample mean minus our population mean. So I'm going to start with putting a left parenthesis in here, and then I'm going to select this value. That's my point estimate or my sample mean. And then the hypothesized value of my population mean is 2.95 or $2.95, which I also included right there. So I'm going to say this is minus that cell right there, and then I'm going to close the parentheses. So that's our numerator right here. And then we're going to say we want to divide this by the standard error. If you recall, the standard error is the standard deviation divided by the square root of our sample size. It's actually this value right here, but I'm going to write a separate formula that does all of this. So again, I'm going to start with left parenthesis, and I'm going to take my standard deviation, which is this value right there, and I'm going to say I want to divide that by SQRT is how you get the square root. And then I'm going to select my sample size right there, and then I have to close the parentheses twice because I did a function kind of within a function right there. When you hit enter, this is going to give you your test statistic right here, which is negative 0.591575. Now we have to calculate our p-value. So if you recall, if we're doing a left tail test, because mu is less than 2.95, that's what's determining that we're doing a left tail test. We're going to be using the cumulative value for the probability from the left. So there's a nice function that does this. It's called the t.dist function. And the inputs for that are going to be the test statistic, the degrees of freedom, and then we have to tell it that we're using a cumulative distribution. So first of all, our test statistic is this value, so I'll select that first. And then I have to separate that with a column or comma. And then the next thing I'm going to have to do is give it the degrees of freedom. So I have my sample size right here, and I could just simply click on that and then say -1. So it's pulling that value in D15, -1. Our degrees of freedom are n-1. And then the last argument is whether or not this is a cumulative distribution. So we want to say true with this. We are using a cumulative distribution, and when we hit enter, that should give us our p-value of 0.279833. So that's how we could get our test statistic and our p-value for this. The other one I want to look at is when we have the case where we have the not equal to sign in H sub A. When we have this sign in H sub A right here, that is indicating that we're doing a two-tailed test. And there's one thing that's a little bit different about this versus what we calculated up here. One way that we could have actually calculated the p-value is taken this value right here and multiplied it by 2 to double it for a two-tailed test, but I'm going to show you a different formula for that. And then the test statistic should be exactly the same, but I'll go ahead and I'll do that function again just in case you missed it the first time. So I'm going to start with an equal sign, left parenthesis, and it is our point estimate minus the hypothesized value of our population mean in the numerator, and I have to close parentheses. So we're calculating the difference between what we have for the point estimate and what we expect to get for the population. And then we're going to divide that by the standard error. One thing I'm going to change a little bit is I'm just going to use the standard error that's already generated right here. And then I'll say enter, and you'll see that I come up with the same exact value that I have had up above for the test statistic, negative 0.591575. Now for our p-value, since we're doing a two-tailed test, we can do this, t.dist. And you'll see when I start typing that in, you'll see that there are a few options. There's this t.dist.2t, which is for a two-tailed test. So I'm going to say dot 2t, and then left parenthesis. And now the inputs for this are the value of the test statistic in the degrees of freedom. Now I'm just going to warn you in advance, this is a negative test statistic, and this function will not operate on a negative test statistic. So I have to do the absolute value of this, so I have the positive value of the test statistic. So I can simply type in ABS, left parenthesis, choose the cell with the value of the test statistic that's negative, and then close parentheses, and that's going to take the absolute value. It'll give us a 0.59157, and then comma. The next thing we have to put in are our degrees of freedom, and degrees of freedom are our sample size minus 1. So our sample size is 25 minus 1, and then close the parentheses. And when we hit enter, you're going to see that that generates my p-value for a two-tailed test right there. So this is how we do this using Excel. The other thing I want to point out too with the p-value, if you take and you double 0.279883, you get that same exact value right there for a two-tailed test. So hopefully this helps you with navigating Excel and generating the test statistic and the p-value for hypothesis testing.